Chapter heading Matrices. Continuation of the same chapter. In the previous video, we discussed about what is a symmetric matrix and a skew symmetric matrix. Listen all of you. What is a symmetric matrix? A transpose is equal to A, and a skew symmetric matrix means A transpose is equal to minus A. And again, A plus A transpose is always symmetric and A minus A transpose is skew symmetric. Okay. Now, write the question. Express the matrix 3 minus 4 and 1 minus 1, 3 minus 4 and 1 minus 1 as the sum of a symmetric and skew symmetric matrix, as the sum of a symmetric and skew symmetric matrix. Very important question. A is equal to 3 minus 4, 1 minus 1. Right. What is A transpose? A transpose is equal to 3, 1 minus 4 minus 1. Interchange the rows and columns. Next, our aim is to express this as a sum of a symmetric and skew symmetric matrix. Then we can form a matrix P such that P is equal to A plus A transpose by 2 and Q is A minus A transpose by 2. Find the answer. What is A plus A transpose? 3 plus 3 is 6 minus 3, isn't it? 1 minus 4 minus 3 minus 1 minus 1 minus 2. Got it? When you divide that by 2, this is 1 by 2 into divided by 2 means 3 minus 3 by 2 minus 3 by 2 minus 1. That is our P. We form another matrix P in this way. Then how can you write Q? Write Q. Q means A minus A transpose. 3 minus 3, 0. Minus 4 minus 1 minus 5. 1 minus minus 4, 5. Minus 1 minus minus 1 is 0. Here also 1 by 2 is outside. When you divide that, what is the answer? 0. Minus 5 by 2. 5 by 2, 0. Got it? Then, next our aim is to show that P plus Q is equal to our question A. Right? That step is also important. P plus Q is equal to A. What is P plus Q? 3 minus 3 by 2 minus 3 by 2 minus 1 plus 0 minus 5 by 2 minus, not 5 by 2, 0. When you add these two, 3 plus 0, 3 minus 3 by 2 minus 5 by 2 minus 8 by 2 is minus 4 minus 3 by 2 plus 2 by 2. 2 by 2 is 1, then minus 1. Okay, that is equal to A. Very important question. Express the following matrix as the sum of a symmetric and skew symmetric matrix. Finish? Now, copy the question from the textbook. All of you copy the question. Express. Right, express A equal to the matrix 2, 1, 3, 1, 1, 4, minus 1, 6, 2 as the sum of a symmetric and skew symmetric matrices and verify your result. Okay, copy A again. A is equal to, then what is A transpose is equal to? Then below write P is equal to, we name it as P. P is equal to A plus A transpose by 2. Do by yourself. A plus A transpose by 2. Check the answer. 2, 1, 1, 1, 1, 5, 1, 5, 2. Got it? Then Q is equal to, what is Q is equal to? A minus A transpose by 2. That is 0, 0, 2, 0, 0, minus 1, minus 2, 1, 0. Again, our aim is to prove that P plus Q, that two answers, when you add that two answers, you will get the answer A. That is the verification. Capital A is P plus Q. Instead of this, we write P plus Q. Yes, do that P plus Q. Is it P plus Q is equal to A? Yes, P plus Q is equal to A. Okay, then below write P plus 2 is equal to A. Therefore, verify the result. Write the next heading. Singular and non-singular matrices. Non-singular matrices. Singular and non-singular matrices. Write down a square matrix capital A. A square matrix capital A is said to be singular. A square matrix capital A is said to be singular if determinant A equal to 0. A square matrix capital A is said to be singular if determinant A equal to 0. Then what is the next heading? Non-singular, determinant A not equal to 0. Singular means determinant A equal to 0 and non-singular means determinant A not equal to 0. Verify the result. Show that the matrix, here not determinant, show that the matrix 3, 5, 6, 10 is singular. Show that 3, 5, 6, 10 is singular. Yes, we can write this matrix as determinant A. Determinant A is the determinant 3, 5, 6, 10. Okay, what is the value of the determinant? 30 minus 30, that is equal to 0. That means it is singular. Okay. Then next question. A equal to the matrix minus 3, 4, 6, 5. Here the chapter heading is matrix, not determinant. But here when you prove that is singular, we find determinant A non-singular, determinant A not equal to 0. Yes, find the answer. Determinant A, put that determinant form minus 3, 4, 6, 5. That means matrix has no value there. When we convert that matrix into determinant form, then only the determinant has a value. Yes, what is the answer? Minus 15 minus 24. The answer is minus 39. That not equal to 0 means that is non-singular. That is non-singular. Okay. Yes, copy the next question. If the matrix write down the question. If the matrix A equal to 5x minus 1, 4 minus 2 minus 3, 7, 2, 2 is a singular matrix. If the matrix A is a singular matrix, find the value of x. Find the value of x. What is the meaning? Singular means the determinant A equal to 0. Expand that 5 into its minor minus x into its minor minus 1 into its minor. Expanding the determinant. You know how to expand the determinant. Okay. Put here This, since it is singular, means determinant A equal to 0. Write that. After solving, you will get x is equal to minus 12 by 29. X is equal to minus 12 by 29. And then write the next heading. Method of finding the inverse of a square matrix of order 2. The method of finding the inverse of a square matrix of order 2. Order 2. Before that, write the heading adjoint of a matrix. Adjoint of a 2 by 2 matrix. I will explain that 3 by 3 later. Adjoint of a 2 by 2 matrix. Right. Suppose the matrix is small ABCD. ABCD is the matrix. Then adjoint is equal to, adjoint of A equal to, interchange the leading diagonal. Here look at the board. Interchanging the leading diagonal. This is D, first A here. Then change the sign of the other diagonal. Minus B minus C. This is adjoint of a 2 by 2 matrix. For example, I will give you one example. A is equal to 3, 4, 6, 7. Then adjoint of A equal to, interchange the leading diagonal. 7 first, 3, interchange. Then change the sign of the other diagonal. Minus 4, minus 6. This is the meaning of adjoint of a 2 by 2 matrix. 2 by 2 matrix. Okay. Here our aim is to find the inverse of a 2 by 2 matrix. Right. Inverse of a 2 by 2 matrix. Write the formula A inverse. A inverse is equal to adjoint A by determinant A. All of you write. A inverse is equal to adjoint A by determinant A. Finish? Write one question. If A is equal to the matrix 1, 3, 2, minus 1. Find A inverse. Find A inverse. Look here. A inverse occur only determinant A not equal to 0. Therefore, first our aim is to find the determinant of this 1, 3, 2, minus 1. Can you say what's the answer? Minus 1, minus 6. Is it minus 7? Right. Minus 7 not equal to 0. Minus 7 not equal to 0. Therefore, inverse exists. Therefore, inverse exists. Okay. Now, how can you find the adjoint? Adjoint of A is interchange the leading diagonal. Minus 1, 1 here. Minus 3, minus 2. Interchange the leading diagonal and change the sign of the other diagonal. Then, can you say what is A inverse is equal to? Adjoint A by determinant A. Write the formula. Adjoint A inverse is equal to adjoint A by determinant A. That is A inverse is equal to minus 1, minus 3, minus 2, 1. The whole by 7 means 1 by 7. Is it right? 1 by 7 into. Or you can write the answer in the fractional form. Minus 1 by 7, minus 3 by 7, minus 2 by 7 or 1 by 7. Or the above line is also correct. A inverse is equal to adjoint A by determinant A. Write the next one. Write one note. A inverse into A is equal to A into A inverse is equal to I. What is the meaning I? I is the unit matrix. I is the unit matrix. If it is of order 2, I means I2 is 1001. That is the meaning of I. A inverse into A is same as A into A inverse is equal to I. Okay. Now write show that show that the matrix 3, 5, 6, 10 is singular. Show that it is singular, hence no inverse exists. Hence no inverse exists. How can you prove that this is singular? Okay, we already done the same question. 30 minus 30, that is equal to 0 means A inverse does not exist. Determinant A equal to 0, therefore A inverse does not exist. Finish? Okay. Then, next one. All of you write. What is the meaning of, right, cofactor? Write the heading, cofactor of an element. Cofactor of an element. All of you copy the question. A is the matrix. Write down 1, 2, 4, 5, 7, 8, 9, 10, 12. Find the cofactors of elements. Write the question. Find the cofactors of elements 7 and 12. I will read the question. Find the cofactors of the elements 7 and 12. All of you look at the board. Here this is 7, isn't it? Our aim is to write the cofactor of, cofactor of 7. Formula minus 1 raised to I plus j into its minor. I will explain. Cofactor of 7 formula minus 1 raised to I plus j. I means which row, j means in which column. I plus j into its minor. All of you look at the board. 1, 2, 4, 5, 7, 8, 9, 10, 12. This is the given matrix. Our aim is to find the cofactor of this 7. All of you write the formula minus 1 raised to. This 7 is in which row? Second row in which column? Second column. Therefore 2 plus 2. Minus 1 raised to I plus j. Ith column. Ith row, jth column. Ith row, jth column. Minus 1 raised to second row, second column into its minor. All of you look at what is the meaning of minor. In the determinant also I explained all this, isn't it? Minor means, suppose your aim is to find the minor of this 7, deleting the row and the column which that particular element occur. Deleting the row and the column. Therefore 5, 7, 8 cancel, 2, 7, 10 cancel. Remaining elements 1, 4, 9, 12. 1, 4, 9, 12. Agree? What is minus 1 raised to 4? Minus 1 raised to 4 is positive. Positive 12 minus 36. Agree? 12 minus 36. What is 12 minus 36? 6 minus 2, 4. 3 minus 1, 2. Minus 24 is the final answer. Our aim is to find the cofactor of 7, isn't it? Now, the cofactor of, what is the element? Next element, right? Cofactor of 12. Cofactor of 12. Look at that. 12 lies in which row? 12 lies in the third row, third column. How can you write? Cofactor of 12 is minus 1 raised to 3 plus 3. Which column? Which row? Which column? Into its minor. Deleting the row and the column which that 12 occur. 1, 2, 5, 7. All of you agree? 1, 2, 5, 7. That is, this here also 3 plus 3 is 6. Therefore, positive. Then 7 minus 10. Final answer minus 3. Plus into minus minus. Minus 3. Okay. That's the meaning cofactor. Next right. Next right. Adjoint of A. Find the adjoint of a matrix A. Find the adjoint of a matrix A 3 by 3 order matrix. I already explained that 2 by 2. Here our aim is to find the adjoint of a 3 by 3 matrix. Adjoint of a 3 by 3 matrix. I will explain that. Right, all of you write. All of you write. To find the adjoint of a matrix, find the the cofactors of each element. Find the cofactors of each element. Cofactors of each element. Then you will get a matrix, isn't it? Then you will get a matrix. Cofactor of each element. Then you will get a matrix. Then take the transpose of the cofactor matrix. Take the transpose of the cofactor matrix. That will give you adjoint of that matrix. First, all of you have to find the cofactor of each element. Cofactor of each element. Then right here, suppose the answer is 2, 3, 5, 8, 9, 6, 5, 2, 9. After finding the formula minus 1 raised to I plus j into its minor, the second, third, like that. Then find the cofactor matrix. This is cofactor matrix. Direct, not the answer adjoint A. Then how can you find the adjoint? Take the transpose of the cofactor matrix. Take the transpose of the cofactor matrix. You will get what? You will get adjoint of the matrix. Adjoint of the matrix. Okay. One example. Write down one question. Find the adjoint of the matrix A. Find the adjoint of the matrix A where A is equal to 1 minus 1, 2, 2, 3, 5, minus 2, 0, 1. Okay. Our aim is to find the cofactor matrix. Right here, LHS is cofactor matrix, not direct adjoint. All of you look here. Here, I am going to draw a big matrix for all of you. Look here. Understand? Then, look here. This is an easy method. Put plus, minus, plus. After this plus, you will get minus, plus, minus. Here the ending is minus. Therefore, the next row starts minus, plus, minus. All of you understand what is this? To find cofactor matrix easily, we use this method. What is the method? Plus, minus, plus, minus, plus, minus, minus, plus, minus. What the reason is minus this the first. What is the meaning? Our aim is to find the cofactor of these 3 into 3, 9 elements. Understand? For that, formula is minus 1 raised to I plus j. What is this? Minus 1 raised to I plus j means this one is in the first row, first column. 1 plus 1, that is 2. Minus 1 raised to 2 is positive. That is why I put here plus. Then second minus, plus, minus, plus, minus, like that. Then plus into, what is the minor of 1? All of you look at the board. Minor of 1 means deleting the row and the column. Write each one. 3501. 3501. What about the second? 2 2, 5, minus 2, 1, isn't it? Then the third one is 2, deleting that, 2, 3, minus 2, 0, 2, 3, minus 2, 0. You have to find the 9 cofactors, 9 cofactors. Then what about the next one? Minus of this one. Say the answer. Minus 1, 2, 0, 1. Then plus into its minor. 1, 2, minus 2, 1. Third one is 1 minus 1, minus 2, 0. Then next one. To find this, isn't it? To find the cofactor of this minus 2. Minus 2 is in the third row, first column. Third row, first column means 3 plus third row, first column, isn't it? Right. The answer is here minus, this is plus. Minus, plus, minus, plus, minus, plus. Change that sign. Here this is minus. After this minus we put plus, not minus. Plus, minus, plus. Therefore plus into, what is its minor? Minus 1, 2, 3, 5. Agree? Then next one, 1, 2, 2, 5. Then the last one is 1 minus 1, 2, 3. Okay. Then after expanding, then you will get again the cofactor matrix is, can you say the answer? 3 minus 12, 6. Check the answer. 3 minus 12, 6. 1, 5, 2. 1, 5, 2. Minus 11. Minus 5, minus 6. So minus 11. Minus 1, 5. This is only cofactor matrix. Or otherwise find the cofactor of each element and substitute. Here I think this is easy method. Put this plus minus plus like that. Then cofactor matrix is there. Then how can you write adjoint? Adjoint of A means take the transpose of the cofactor matrix, that is 3 minus 12, 6. That changes to the column. 1, 5, 2. Agree? Minus 11, minus 1, 5. This is adjoint of a 3 by 3 matrix. Okay, study all this. If any doubt, I will explain in the next class. Okay, God bless you.